EES, which is pronounced EES, is an acronym for Engineering Equation Solver. In the last few videos, we've been talking about the basic process associated with setting, checking, and converting between units. In this video, we're going to discuss particularly units of temperatures and units of temperature differences. Most unit conversions require only a multiplicative operation using the conversion factor that can be provided by the convert function in EES. And you can see here what the convert function is actually doing when I want to convert between feet and meter. It just provides a number, and then I can just multiply by that number. Temperatures, though, have to be dealt with a little more carefully. If I want to convert from one temperature scale to another, then in general I'm going to both multiply and add. So for example, here's the equation that I would use to go from a temperature in degrees Fahrenheit to a temperature in Kelvin. Multiplying by a conversion factor returned by the convert function doesn't work. If you want to convert from a value of one temperature scale to another temperature scale, that's not the appropriate process. So for example, the temperature in my office right now is about 70 degrees Fahrenheit. If I was interested in determining what the temperature is in my office in Kelvin, I couldn't just write this equation here. I couldn't use the convert function to do this. If I hit solve, you can see that this is giving me 38.9 Kelvin, which is ridiculously cold and obviously not right. You can see here in the formatted equations window that the convert function is taking care of the multiplication by 0.556, but it's not dealing at all with the addition of 255.4 that's required to actually convert correctly. So the ConvertTemp function in EES is what you need if you want to convert between temperature scales, because it internally does both the multiplication and the addition that's required. The ConvertTemp function accepts three arguments. The first argument indicates the temperature scale to convert from. The second argument indicates the temperature scale to convert to. And then the third argument is the actual numerical value or variable or expression that you would like to be converted. The temperature scale indicators can be F, C, K, or R, representing Fahrenheit, Celsius, Kelvin, and Rankine scales respectively. So for example, here, this is how I would correctly convert from 70 degrees Fahrenheit in my office to the Kelvin temperature scale. And the result you can see is a much more reasonable 294.3 Kelvin. Notice that the unit checking in EES correctly interprets the ConvertTemp function as it does all of EES's internal functions. So ConvertTemp, when it's called with these temperature indicators, expects that T sub F has units of Fahrenheit and T sub K has units of Kelvin. And if I don't set the units of those variables up in that way, it will give me a unit conversion error. So there can be confusion in temperature units because sometimes you're interested in converting a temperature difference from one scale to another. And if that's the case, then you would not use the ConvertTemp function, but rather then you would use the convert function. So for example, if I wanted to convert a temperature difference from degrees Celsius to Fahrenheit, I would use convert C, F. So for clarity, EES does provide temperature difference units, delta F, delta C, delta R, and delta K. And it's best practice to use these to make it clear what you're actually talking about. So for example, my office is 70 degrees Fahrenheit, and the outdoor temperature might be 20 degrees Fahrenheit colder than my office. So 70 is a temperature on a temperature scale, 20 degrees is a temperature difference. If I want to know both my office temperature and the outdoor temperature in a different temperature scale, then I need to be a little careful. So I'm going to enter both inputs, and I'll convert them to, for example, Kelvin. So here I will enter the 70 Fahrenheit, and I'll use the ConvertTemp function to convert from Fahrenheit to Kelvin, and that would give me my office temperature. However, the 20F temperature difference is a temperature difference, and it should not be converted to Kelvin using the ConvertTemp function. Instead, I'll enter that temperature difference with units of delta F to indicate that it's a difference, and I'll use the convert function to go from delta F to delta K as shown here. And I find out the temperature difference in Kelvin is 11.1 Kelvin. So now if I add these together in the right way, I find that the outdoor air temperature is 283.1 Kelvin as shown here. The use of the temperature difference units is particularly important when you're using an alternate units option, because EES will automatically assume that any variable having units of Fahrenheit, C, R, or Kelvin is a temperature rather than a temperature difference. So, for example, if I had entered this temperature difference with units of Kelvin here, and then I set the alternate units of the temperature difference to Fahrenheit, the answer is just wrong. This is one of a series of tutorials that is meant to describe the operation of the EES software. If you'd like to get more information about EES, obtain the software, or access more of these tutorials, please go to the website fchart.com. These tutorials are excerpted from the book Mastering EES, and that book can also be obtained from the fchart website.